The FIA finally unveiled the regulations that will come into effect in 2026, developed by the technical working groups and written in collaboration with Formula One, the 10 teams, the original equipment manufacturers, and the sports power unit manufacturers. The regulations will be ratified by the World Motorsport Council on June 28 and are designed to create greater competition between cars, more safety, and increased sustainability. Teams will be able to work on aerodynamics starting January 1, 2025, while they can develop the chassis and mechanical parts immediately. Stefano Domenicali, CEO of Formula One, indicated that these regulations mark a significant moment in the future of the sport, as they look forward to a new generation of cars and power units that aim to provide fans with closer and more exciting races. The renders shown are related to the 7th revision of the regulations. However, the latest version is the 10th, which may indicate how far the visuals could be from the final reality. At the core of the new regulations is the concept the International Federation has defined as the Nimble Car, which aims to further enhance the spectacle with even closer races. Commenting on the progress contained in the 2026 regulations, FIA single-seater technical director Nikolas Tombazis noted that the FIA has sought to develop a new generation of cars that are fully in touch with the DNA of Formula One: lightweight, extremely fast and agile, but also at the cutting edge of technology. The cars expected on the track in the 2026 season will weigh 768 kilograms, 722 kilograms of car and driver, plus 46 as the estimated mass of the tires, making them 30 kilograms lighter than the current generation of F1 cars, improving efficiency and handling. Weight reduction was not the only key objective, as the new cars are also designed to be smaller. The wheelbase drops from a maximum of 3,600 millimeters to 3,400 millimeters, while the width has been reduced from 2,000 millimeters to 1,900 millimeters. The maximum floor width will then be reduced by 150 millimeters. The car concept has been designed to adapt to the new engine challenge undertaken by the Federation, which sees the power of the internal combustion part drop from 560 kilowatts to 400 kilowatts, while the battery element increases enormously, going from 120 kilowatts to 350 kilowatts with an almost 300% increase in electric power. Additionally, the amount of energy that can be recovered during braking has doubled, with a total recoverable energy of 8.5 megajoule per lap. This has resulted in cars with a 30% reduction in aerodynamic downforce, and most importantly, with 55% less aerodynamic drag. Regarding wheel size, the 18-inch rims will be retained, although the width of the front tires will be reduced by 25 millimeters and the rear by 30 millimeters, with minimal loss of grip. The new generation of cars, debuting in the 2026 season, will feature not only entirely new chassis, mechanics, and aerodynamics, but also significantly revised engines developed from the current base, which are the most efficient units in the world. The new regulations have led to commitments from existing suppliers like Ferrari, Mercedes, and Renault, as well as the return of Honda as a manufacturer and the entry of Audi and Red Bull Ford powertrains. Vincent Perrine, the FIA head of powertrain, expressed pride in reaching a global agreement with 6 engine manufacturers and Formula One, highlighting it as a significant team effort. Starting with the regulations for the new engines, the International Automobile Federation then drafted the chassis part, designed to eliminate issues with current cars such as high rigidity and important limitations due to the new engines, which are more reliant on the electric component compared to the current ones. Increasing the dependence on the electric component introduces other significant risks, such as the inability to continuously power the electric motor. This led to the introduction of active aerodynamics, which will reduce drag by 55% in the next generation of cars thanks to the X mode, a specific configuration of the front and rear wings to be used on straightaways, where all attack angles will be nullified. This resulted in a complete revision of the system dedicated to overtaking, effectively removing DRS as indicated by the Federation months ago, and introducing the manual override system, which allows the use of the electric motor for a longer period on straightaways compared to a competitor. The override function, similar to DRS, will allow a car within a certain distance before the end of a lap from the car ahead to use more electric energy the following lap. This will provide 0.5 megajoule more than the usual 8.5, a 6% increase, but the key difference is the additional power available on straightaways, where the difference between the two mappings could exceed 200 horsepower above 300 kilometers per hour. The extra electric energy is intended to replace the opening of the rear wing and give a car an extra boost for overtaking. The 2026 regulations are based on the ability to have an aerodynamic concept that reduces negative impacts on the following car, as being close to the car ahead is necessary for overtaking. If both cars have their rear wings and front wing flaps open, the following car will be allowed to distribute more electric energy for a certain period during that lap to aid overtaking. The logic remains the same as usual. Being close to another car will provide an extra amount of energy for that lap, usable as desired. With the override mode, the use of maximum power, 350 kilowatts, will be extended up to 337 kilometers per hour, whereas with the standard mapping, drivers can use the 350 kilowatts of maximum power up to 290 kilometers per hour. Above that speed, the kilowatts of electric power will progressively decrease until reaching zero at 355 kilometers per hour. Similarly, with the standard mapping at 339 kilometers per hour, drivers will only have 105 kilowatts of power, which will drop to zero at 345 kilometers per hour, leaving only the thermal component to drive the car. This detail was explained by Jason Somerville, head of the FIA's aerodynamics department, who mentioned it was developed during the process based on simulation results with teams and drivers. Drivers were uncomfortable with the car's balance when the rear wing was so unloaded while the front had much more downforce. This led them to consider a movable flap on the front wing. Unlike the current DRS system, which does not create this aerodynamic imbalance between the front and rear, the new rear wing will have more movable elements, 3 in total, and a greater opening, leading to a lower downforce level and consequently a greater reduction in drag, more powerful than the current DRS system. The implementation of a movable front wing is not entirely new to Formula One. In 2009, the technical regulations allowed its use, but since it was not widely used, it was eventually removed. This recollection was shared by Somerville. There has been some skepticism regarding active aerodynamics, mainly due to past experiences where its use was negative and posed some risks. Adrian Newey recently expressed that modern Formula One is better equipped to handle such technology, and many problems from the past would not occur today. This view aligns with the FIA's stance. Somerville explained that improving aerodynamic efficiency is always beneficial, and if it can be achieved this way, it should be considered, noting that similar technology is also seen in some road cars. Aerodynamic efficiency was a significant factor in focusing on this element. If a 2026 power unit were placed in current cars, there would be a drastic decrease in speed at the end of a standard main straight. Therefore, it was necessary to find a way to significantly reduce drag without sacrificing downforce, according to the English engineer and FIA head of aerodynamics. It is understood that the 2026 regulations are still based on having an aerodynamic concept that reduces the negative impacts on the following car, because to overtake, it is necessary to be close to the car in front.